Hello everyone. Today I'm going to talk about molecular orbitals. And so, I'm going to explain everything that's required of molecular orbitals and give you a basic understanding just to begin your understanding of molecular orbitals. I used understanding a lot in that phrase. But anyway, before you really get into this video, I suggest that you know something about atomic orbitals as well as valence electrons. Probably watch some videos on it. Just need a basic understanding of those. Those are the prerequisites for this video. So then, for the wonderful and amazing molecular orbitals. Today I'm going to talk mainly about fluorine, and if I have time I might talk about other molecules. But these are homonuclear molecules because it is the same molecule, therefore it's homo, and they will form the homomolecular bond. And so what I'm going to do real quick is show you the Lewis structure of fluorine right up here. And if you'll notice, fluorine follows the octet rule, which you have probably heard of by some point up to this level, and you have this one single bond here. Molecular orbital theory, or MO theory, can give you a basic understanding of what goes into that bond. But enough on that. So before we can truly move on to all these lines I've drawn below, I'm going to give you the electron configuration for fluorine. So we have 1s2, 2s2, and 2p5. Now that is for fluorine. That means that this... let me change my color real quick. The area right here is the valence electrons, and that is what we're going to concern ourselves with in molecular orbitals, is just the valence electrons. As far as the whole other pre-existing electron shielding electrons, we don't care about. So enough on that. Let's get on to the actual fun stuff of molecular orbitals. So what we have here is two distinct areas. We have let me change my color back to black. We have this lower region, and we have this upper. And then, if you'll also notice, we have fluorines on both sides. We have a fluorine here, and we have a fluorine here. And so all this stuff in the middle is what goes into that single bond of fluorine. So that is equal to this. And so what we're going to start to do is fill in the orbitals. So this is going to be the the 2s orbital for this fluorine molecule here, and this is going to be the 2s orbital for this fluorine. Now if you remember back to the valence electrons, you'd know that it was 2s2, so they each get 2 electrons. Now what these 2 electrons are going to do is they are going to attempt to bond. So they are going to go to these other lines that I have in the middle. Now the other lines that I have in the middle are going to fill with the electrons. So we have 2 electrons on this side, 2 of the electrons on this side. This side is going to donate 1 electron to this bottom level, as is this one. And this bottom level is what we call the sigma bond. So it's a sigma G bond. And this is for the 2s orbital. Okay, the 2's not necessary, but the 2s sigma ground bond. However, that's only 2 of the electrons that are involved in the bond. There are 4 available, because as you can count, there's 1, 2 on this side, 1, 2 on this side, so 2 plus 2 equals 4. Duh, right? In the center, we have 1 and 2. So obviously these extra 2 electrons will need to go somewhere. So they will go in this upper line. This upper line, let me just clear everything up. Oop, wrong button. This upper line is called the sigma U anti-bond. That asterisk right there, let me draw it more clearly. Just a standard asterisk means anti. So this is always associated with anti-bonds. And this is for the 2s. So sigma anti-2s. If the anti-bond is equal to the sigma bond, well, or the normal bond, then no bond is formed. But we'll talk more about that in just a moment. So then we have up here the p orbitals. We have 5 electrons because we have 2p5. And they are going to do the same thing here, which makes things easier. However, you have these new lines in here. These new shiny lines are going to be pi bonds. So this is going to be still a sigma G, but it's going to be 2p. This is going to be a pi G 2p, a pi G 2p, and then this is going to be, as you probably have guessed, pi anti, which is a U 2p, pi anti U 2p. And then up here at the highest energy level is the anti-sigma bond for 2p. And so we are going to fill in the electrons. So we have 5 on each side, which is a total of 10 electrons, so 10 electrons must fill these center lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the pi bond and the anti-pi bond, if you'll notice, are filled. That means that there is no pi bonds in the fluorine molecule, which is to be expected because fluorine is just one of those molecules. But another thing to know is that when it comes to p orbitals, those and their peanut shape to them, you have an x which goes in the x-plane of a three-dimensional graph. You have also the y, which will go up and down, and you'll have the z. And so each one of these orbitals on each side gets that specific name. So you have your x, y, z. X, oh, actually it's x, y, z. So each one of these pi and sigma bonds in the middle have respectively z, z, and then you have y, y, x, x. And that is the basics of it. As you notice, the X ones will actually fill the X 2Ps, the Y ones will fill the 2 Ys, and the Zs will fill the Z orbitals. Right, thank you for watching. I will have more in the next video on some weirder molecules.